Hello, David.
Hello, James. Could you tell me what was the homework for computer science today?
We're supposed to write a program to print the Fibonacci series.
Pardon me, what are we supposed to print?
The Fibonacci series?
What's that?
You never heard of Fibonacci series? It's everywhere. In fact, it was mentioned in our history, mathematics, and art classes today.
Well, I clearly picked a bad day to be sick from school. Tell me more.
To put it as concisely as possible, the Fibonacci sequence is a sequence of numbers such that each number is the sum of the two preceding ones. The first two numbers are 0 and 1. The numbers which represent the series generate geometrical patterns which can be found in all aspects of life, from the physiology of plants and animals to the sex ratio of bees. The general representation of the series is f0 is equal to 0, f1 is equal to 1, and the general formula is fn is equal to f of n minus 1 plus f of n minus 2. In our history class today, we were learning about famous inventions in mathematics. India was responsible for many mathematical inventions like the decimal number system we use today, the concept of zero as a number, the modern definitions of sine and cosine, and many more. Among these amazing inventions was the Fibonacci series, which is only discovered by Fibonacci a century later.
But how did he come up with the idea of it? What made him think of such a particular series of peculiar numbers?
Our mathematics teachers posed us the same problem, which led to his discovery of the series. It goes like this.
Suppose a newly born pair of rabbits are put in a field. Rabbits are able to mate at the age of 1 month so that at the end of its second month a female can produce another pair of rabbits. Suppose that the rabbits can never die and the female always produces one new pair every month from the second month on. How many pairs will there be in 1 year? Thus we get the following sequence of numbers. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144. This sequence, in which each number is a sum of two previous, is called Fibonacci sequence. So 144 pairs will be there at the end of 1 year.
Wow, that's a really smart way of thinking about the problem. But I still don't see how the series is relevant to art.
It's present in almost every work of art because of how common it is in nature.
Number of petals and flowers are often Fibonacci numbers. Flowers, specifically daisies, have either 34, 55 or 89 petals. These numbers are the 9th, 10th and 11th Fibonacci numbers respectively.
And the numbers have some peculiar properties.
The ratio between two successive Fibonacci numbers would eventually give us golden ratio. If the longer segment is divided by the smaller segment is also equal to the whole length divided by the longer part, then you gain a golden ratio. It is highly unusual for decimal integers of a number and its reciprocal to be exactly the same. Mona Lisa's face is a perfect golden rectangle. The front two incisor teeth form a golden rectangle with a phi ratio in the height to the width.
Thanks a lot. I'd better get started on that homework now.